So, hello guys. Today we are going to study the chapter acid, bases, and salt. We will study NCRT line by line, and I will tell you what are the important things that will be helpful for your board examinations as well as other examinations you might give. So, let's start without wasting much of the time. You have learnt in your previous classes that the sour and bitter tests of food are due to acids and bases respectively present in them. If someone in the family is suffering from a problem of acidity and after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar, or baking soda solution? Actually, he's telling that if some of our family member is suffering from the problem of acidity, means the release of HCl in our stomach is more than as it was required. So he is suffering from acidity. So to neutralize it, we will need some base, and we will study in this chapter what is an acid, what is an base, and we will learn to identify which is an acid and which is a base. Which property do you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tested sour and bitter substances without tasting them. You already know that acids are sour in taste and change the color of blue litmus to red, while bases are bitter and change the color of red litmus to blue. You may note this line that acids are sour in taste and change the color of blue litmus to red, and whereas bases are bitter and change the color of red litmus to blue. You will have to note this line. So I am highlighting it for your reference. So what is litmus? Litmus is a natural indicator, and turmeric is another natural indicator. Have you noticed that a stain of curry on a white cloth becomes reddish brown when the soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. Here we got that soap is basic in nature. Okay, and turns turmeric turmeric turns reddish brown when soap is applied to it. So we can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. Some of the synthetic indicators that we can use are methyl orange and phenolphthalein. So, in this chapter, we will study the reactions of acids and bases, how acids and bases cancel out each other's effect, and many more interesting things that we use and see in our day to day lives. So, in the do you know about litmus is given, which is not important for the board exam, but in competitive exam, it might be asked about litmus. Litmus solution is a purple dye which is extracted from lichen, a plant belonging to division Thallophyta and commonly used as an indicator. When litmus solution is neither acidic nor basic, its color is purple. There are many other natural materials like cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, and geranium, which indicate the presence of acid or base in a solution. These are called acid base indicator or sometimes simply indicators. So, what do you mean by indicators is that the substances those who indicate or show an acid or an base, or which is an acid, which is an base, which is a base, is called as indicator. Now, Understanding the chemical properties of acid and base. Referring to activity 2.1, collect the following solutions from science laboratory: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, and ammonium hydroxide. These all acids and their formula which are written here are important for your board exam. So please refer to that. Put a drop of each of above solution on a watch glass one by one and test with a drop of indicator shown in table 2.1. What changes in color did you observe with red litmus, blue litmus, phenolphthalein, methyl orange solution for each of the solutions taken? Tabulate your observation in table 2.1. These indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose odor changes. Odor means the smell. Odor changes uh, in acidic or basic media. These are called olfactory indicators. What are olfactory indicators? The substances whose odor changes or smell changes in acidic or basic media. They are called as olfactory indicators. Activity 2.2. Take some finely chopped onions in a plastic bag along with some strips of clean cloth. Tie up the bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take two of these cloth strips and check their odor. Keep them on a clean surface and put few drops of dilute hydrochloric acid or HCl solution on one strip and few drops of dilute NaOH or sodium hydroxide solution on the other. Rinse both cloth strips with water and again check their odor. Note your observations. Now take some dilute vanilla essence and clove oil and check their odor. Take some dilute hydrochloric acid solution in one test tube and dilute sodium hydroxide solution in another. Add a few drops of dilute vanilla essence to both test tube and check well. Check the order once again and record changes in order if any. Similarly, test the change of order of clove oil with dilute hydrochloric acid and dilute sodium hydroxide solution and record your observation. Which of these vanilla, onion, clove can be used as olfactory indicators based on your observation? So we got here that vanilla, onion, and clove are examples of olfactory indicators. Okay, highlight that olfactory indicators. Now we will see how do acids and bases react with metals. So set an apparatus as shown in figure 2.1. Here is an apparatus that is shown. Take about 5 ml of dilute sulfuric acid in a test tube and add few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Past the gas being evolved through the soap solution. Why are bubbles formed in the soap solution? Take a burning candle near a gas filled bubble. What do you observe? Repeat this activity with some more acids like hydrochloric acid or HCl, nitric acid or HNO3, and CH3COOH or acetic acid. Are these observations in all cases the same or different? So here is the apparatus that is shown reaction of zinc granules with dilute sulfuric acid and testing hydrogen gas by burning. So we will see that in the above reaction, displacement reaction takes place, which we have studied in class 9, and the hydrogen atoms are displaced from the acids as hydrogen gas and forms a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus base gives us salt and hydrogen gas. Okay, so now activity 2.4. Place a few pieces of granulated zinc metal in a test tube. Add 2 ml of sodium hydroxide solution and warm the contents of the test tube. Repeat the rest of the steps as in activity 2.3 and record your observations. So we are checking here zinc and adding sodium hydroxide to it. So the following reaction takes place. Sodium hydroxide added with zinc gives us sodium zincate, Na2ZnO2 and hydrogen gas. Sodium zincate here is a salt which we found above that acid is a base when reacts with a metal gives us a salt and hydrogen gas is evolved. So acid plus metal gives salt and hydrogen gas. Okay. So now how do metal carbonates and metal hydrogen carbonates react with acids? We will take two test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate in a test tube A and about 0.5 gram of sodium hydrogen carbonate in test tube B. Add 2 ml of dilute hydrochloric acid to both the test tube. What do you observe? Pass the gas produced in each through lime water calcium hydroxide solution. So here lime water is referred as calcium hydroxide, or calcium hydroxide solution is commonly called as lime water. So and as shown in the figure 2.2 and record your observation. The reactions occurring above in the above activity are written as when sodium carbonate reacts with hydrochloric acid, it produces sodium chloride, water, and carbon dioxide. These reactions are very important for your board exams, so please make a note of it. Now, sodium hydrogen carbonate, when reacts with hydrochloric acid, produces the same products, that is sodium chloride, water, and carbon dioxide. On passing carbon dioxide gas evolved through lime water, we get the following, that is CaCO3 or calcium carbonate and water. So, calcium hydroxide plus carbon dioxide will give us calcium carbonate plus water. Calcium carbonate's color is white or white precipitate is formed in the reaction. So, it is to be noted that calcium carbonate is white in color. This may be act as short questions in your board exams or other examination. On passing excess carbon dioxide, the following reaction takes place. Calcium carbonate, water, and carbon dioxide forms calcium hydrogen carbonate. Calcium hydrogen carbonate or calcium hydrocarbonate is a compound which is soluble in water. It is to be noted. Limestone, chalk, and marble are different forms of calcium carbonate. What are the colors of limestone, chalk, and marble? Is it white? So we infer here that calcium carbonate is white in color, or the white precipitate we got in the above reaction is calcium carbonate. So we come to the conclusion that all metal carbonates and hydrogen carbonates reacts with acid to give a corresponding salt, carbon dioxide, and water. Thus, the reaction can be summarized as metal carbonate slash metal hydrogen carbonate with acid gives salt, carbon dioxide, and water. So, coming to next, how do acids and bases react with each other? Activity 2.6. Take about 2 ml of dilute sodium hydroxide solution in a test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Add dilute hydrochloric acid to the solution, above solution drop by drop. Is there any color change for the reaction mixture? Why did the color of phenolphthalein change after addition of an acid? Now, add a few drops of sodium hydroxide to the above mixture. Does the pink color of the phenolphthalein reappear? Why do you think this has happened? So, in the above activity, we observe that the effect of a base is nullified by an acid and vice versa. So, in the above activity, the following reaction takes place. Sodium hydroxide reacts with hydrochloric acid to produce sodium chloride and water. So this can be termed as A neutralization reaction, or the reaction between an acid and a base to give salt and water, is called as the neutralization reaction, which can be written as base plus acid is equal to or gives salt plus water. So reaction of metallic oxides with acid. How do metallic oxide react with acid? Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to copper oxide? You will notice that the color of the solution becomes blue green and copper oxide dissolves. The blue green color of the solution is due to the formation of copper 2 chloride. Copper 2 chloride is a salt. It is to be noted, and its color is blue green. And the reaction can be generalized as metal oxide plus acid gives us salt and water. So here the copper oxide, when we add dilute hydrochloric acid to it, it forms copper 2 chloride or cuprous chloride and water. Now, now if you are told to write the reaction of it, I am writing it here. Please see it. Okay. So the copper oxide is C2O. When it reacts with hydrochloric acid or HCl, pardon my handwriting, gives CuCl2 plus water as a byproduct, H2O. So now let us balance the reaction. So copper 1 is here, copper 1, oxygen here 1, okay. Hydrogen is 2, so make adding 2 to it. Sorry, just a minute. Adding 2 to the HCl, and we get chloride as 2. So this reaction is balanced now. So in the above activity, this reaction takes place. So now write and balance the equation for the above reaction which I have written above. Since metallic oxide react with acids to give salt and water, similar to the reaction of base and acid, metallic oxides are said to be basic oxide, or metallic oxides are basic in nature. It is to be noted that metallic oxides are basic in nature, or metallic oxides are said to be basic oxide. So now we will see reaction of a non-metallic oxide with base. So uh, you saw the reaction between carbon dioxide and calcium hydroxide, that is lime water, in activity 2.5. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce salt and water. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce salt and water. Since this is similar to the reaction between a base and an acid, we can conclude that non-metallic oxides are acidic in nature. Non-metallic oxides are, sorry, wait a minute. Non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. Okay. Though these in-text questions are to be solved by you, I will upload the solutions to the in-text question in the description box. If first solve it by your own and then check for the answers from it, or else you can refer to the answers behind your book or any of the NCRT solution in the books you can find. Okay. So what do all acids and all bases have in common? In section 2.1, we have seen that all acids have similar chemical properties. What leads to this similarity in properties? We saw in the activity 2.3 that all acids generate hydrogen gas on reacting with metals. All acids generate hydrogen gas on reacting with metals. So, hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds contain hydrogen or acidic. Take solution of glucose, alcohol, hydrochloric acid, and sulfuric acid. The formula for glucose is C6H12O6. Biology studying students may know it. Alcohol, you can take any alcohol which has an OH functional group in it. Hydrochloric acid is HCl, sulfuric acid is H2SO4. So fix two nails on a core and place the core in a 100 ml beaker as shown in the figure 2.3. It is telling you to design the apparatus. Connect the nails to two terminals of a 6-volt battery through a bulb and a switch as shown in figure 2.3. Basically, it is performing electrolysis, or if the means if passing current through the if the current is passed through the solution, we will be confirmed that the presence of ions in the solution, and we will confirm that H plus ions are present in it, and which when come out, it comes as in the form of hydrogen gas. So now pour some dilute hydrochloric acid in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solution. What do you observe now? Does the bulb blow in all the cases? The bulb will start glowing in case of acids as shown in figure 2.3. That means acids conduct electricity, but you will observe that glucose and alcohol solution do not conduct electricity. Glowing of bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the acidic solution by ions. So acids and bases contains ions which support the, or which makes the current flow in the solution. But in case of glucose and alcohol solution, which are carbon compounds, which we'll study in the chapter 4. So these are carbon compounds and they do not conduct electricity. So now there is something to be noted that acid contains H plus ion as cation and anion such as Cl minus in HCl, NO3 minus in HNO3, SO4 2 minus in H2SO4, CH3CO minus in CH3COOH. HCl is hydrochloric acid, HNO3 is nitric acid, H2SO4 is sulfuric acid, CH3COOH is acetic acid. Okay, so these acids contains H plus ion as cation or positive ion, and Cl minus ion, Na3 minus ion or nitric ion, sulfate ion, and acetic ion as anions respectively. So since the cations present in the acids is H plus, this suggests that acid produce hydrogen ion or H plus aqueous in solution, which are responsible for their acidic properties. So here we get that the uh, acidic properties shown by the acids are due to the presence of H plus ion in it. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide, etc. What can you conclude from the result of this activity? Alkalis means nothing but base. Okay, sodium hydroxide and calcium hydroxide are bases whose formula are NaOH and COH whole 2. Okay, so now we will see what happens to an acid or base in water solution. Do acids produce ions only in aqueous solution? Let us test this. Take about 1 gram of sodium chloride in a clean, and sodium chloride is common salt. Okay, so in a clean and dry test tube and set up the apparatus as shown in figure 2.4. With some of the concentrated sulfuric acid in the test tube. What do you observe? Is there a gas coming out of the delivery tube? Yes, the gas evolves successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do we infer about the acidic character of dry HCl gas and HCl solution? Okay. So this experiment suggests that hydrogen ions in HCl are produced in presence of water. The separation of H plus ion from HCl molecules cannot occur in the absence of water. So it is telling that H plus ions get separated from Cl minus ions in the solution in hydrochloric acid only in the presence of an aqueous medium or water. Only dry HCl gas, if we pass, then there will be no separation of H plus ion and Cl minus ion. And as in the above experiment, we have been passing electricity, so it will the dry HCl gas will not conduct electricity as long as it is not in aqueous solution or present in water. So HCl, when added to water, becomes H3O plus or hydronium ions and chlorine Cl minus ion or chlorine ions. So H plus ions or hydrogen ions cannot exist alone, but they exist after combining with water molecules. So here, what happens that the the H plus ions combine with water H plus ions combine with water to produce H3O plus. Okay, wait a minute. H2O to produce H3O plus ion. Okay, as H plus ions cannot exist alone, it combines with H2O or water to produce H3O plus ions. Okay, or hydronium ions. They are called as hydronium ions. So, okay, the reaction was written here. I wrote it once again. So, please refer this if you can't read this. Okay. So, we have seen that acids give H3O plus or H plus aqueous ion in water. Let us see what happens when a base is dissolved in water. Similarly, when a base will dissolve in water, what happens? We will see now. Sodium hydroxide, when dissolved in water, gives Na plus ion and OH minus ion, or sodium cation and OH minus or hydroxide anion. It is to be noted. Okay. Similarly, potassium hydroxide, when dissolved in water, gives potassium ion or K plus ion and hydroxide ion. Magnesium hydroxide, when dissolved in water, gives magnesium ion and hydroxide ion. Magnesium ion is written as Mg2 plus. Okay. So bases generate hydroxide ions in water. Bases generate hydroxide ions in water. And it is to be noted that bases which are soluble in water are called as alkalis. Okay. Bases which are soluble in water are called as alkalis. So all bases do not dissolve in water. An alkali is a base that dissolve in water. They are soapy to touch. Bases bases have some property. They are soapy to touch, bitter in taste, and corrosive. Never taste or touch them as they may cause harm. Okay. So now, as we have identified that all acids generate H plus aqueous ion or hydronium ions, and all bases generate OH minus aqueous ions or hydroxide ions, we can view the neutralization reaction as follows. When acid and bases react, it produces salt plus water. We have seen in the neutralization reaction the H plus ion present in an acid and OH minus ion present in a base combine to produce water, and the remaining cation part of base and anion part of the acid combine to form a salt. Here it is shown and depicted as reactions. You may take a note of it. Okay. So now we will conduct activity 2.10. 10 ml of water in a beaker. Add a few drops of concentrated H2SO4 to it and swirl the beaker slowly. Swirl means uh, to shake it or to basically it is to be done to mix those. Okay, so so touch the base of the beaker. Is there is a change in temperature? Is there a change in temperature? Is this an exothermic or endothermic process? Basically, what are exothermic and endothermic process is that exothermic processes there is a evolution of heat or the reaction produces heat. While in endothermic process, the reaction takes heat and there is a there is a decrease of temperature. Means the reaction when reactants require heat to uh, form product in endothermic process and in exothermic process the reactants while making product produce heat as a product. Okay, so it is to be noted exothermic and endothermic processes are to be noted. Okay, so repeat the above activity with sodium hydroxide pellets and record your observation. The process of dissolving an acid or base in water is highly exothermic one. Care must be taken while mixing concentrated nitric acid or concentrated sulfuric acid with water. The acid must always be added slowly to the water. This may be asked in competitive examination. Acid must be added slowly to water, not water to acid, not anything or the other likewise. Okay. Acid must be added slowly to the water with constant stirring to decrease the temperature. If water is added to concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. Okay, these are the causes why we do not add water to concentrated acid. Heat generated may cause the mixture to splash out, and acids on your skin may cause burns. And the glass container may also break due to excessive local heating. Look, look out for the warning sign on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in decrease of the concentration of ions H3O plus or hydronium ion, OH minus or hydroxide ion per unit volume. Okay. So this point is to be noted. Such process is called as dilution, and the acid or base to be is said to be diluted. We have used the terms diluted sulfuric acid, diluted sodium hydroxide in the previous activities. So this is the explanation for this. Diluted hydrochloric acid means the acid is water. Acid is added to water slowly, and it is made dilute. So now we will study about how strong are acid or base, or we will see that we will find the relative strength of acid or base solutions. Okay, so we know that acid base indicators can be used to distinguish an acid and a base. We have also learned that in previous sections about dilution and decrease in concentration of H plus or OS minus ions in solution. Can we quantitatively find the amount of these ions present in a solution? Can we judge how strong a given acid or base is? We can do this by making use of a universal indicator, which is a mixture of several indicators. What is an universal indicator? An universal indicator is a mixture of several indicators. Okay? The universal indicator shows different colors at different concentration of hydrogen ions in a solution. A scale for measuring hydrogen ion concentration in a solution is called as pH scale, which has been developed. The P in pH stands for potens in German. Okay, meaning power. P in pH stands for potens, which means power in German. On on the pH scale, we can measure pH generally 0 to 14. 0 means very acidic, 14 means very alkaline or basic. pH should be thought of as simply as a number that which indicates the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower the pH value. It should be noted, higher the hydronium ion concentration or H plus ion or H3O plus ion concentration, lower the pH value. On a pH scale, acid is on the left side and bases are on the right side. Okay. So the pH of neutral solution is 7, value less than 7 on the pH scale represent acidic solution. As the pH value increased from 7 to 14, it represents an increase in OH minus ion concentration in the solution, that is, increase in the strength of alkali. Generally, paper impregnated with the universal indicator is used for measuring pH. Okay. So this is basically the pH variation of pH with change of concentration of H plus aqueous and OH minus aqueous ion. You can refer the figure and understand the above mentioned things. Okay. So then test the pH values of the solution given in the table 2.2. Record your observation. What is the nature of each substance on the basis of your observation? Saliva, before meal, after meal. Lemon juice, colorless aerated drink, or means carbonated aerated drink, carbonated drink, colorless that you can use limca type of soft drinks, and carrot juice, coffee, tomato juice, tap water. 1 mole. This is 1 mole of sodium hydroxide, and this is 1 mole of, or it refers molarity of hydrochloric acid. Okay, this is the common depiction of a pH paper. Okay, so the colors represented here only, it is for illustrative purpose. So you may not refer this color as proper colors, but you can see that there is mentioned gastric juice or gastric juice which have pH about 1.2, lemon juice pH about 2.2, pure water or blood pH about 7.4, milk of magnesia pH is 10, sodium hydroxide solution pH is about 14. These pH values or relation among the pH values of gastric juice, lemon juice, pure water, blood, milk of magnesia, sodium hydroxide solution is commonly asked in each and every competitive exam which conducts the paper of general studies or science. So please make a note of it. Okay. The strength of acid and bases depend on the number of H plus ions and OH minus ions produced, respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then these produce different amounts of hydrogen ions. Acid gives rise to more H plus ions, and acids that give rise to more H plus ions are said to be strong acid, and acids that give less H plus ion are said to be weak acid. And you can now say that what are weak and strong bases? Weak bases are those which gives less what? Less hydroxide ion, and strong bases are those which gives more hydroxide ions. Okay, so we can define weak and strong bases like that. The rest part of the chapter I will cover it in my next video. I think the video has become very long as of now. Please share a review about what changes I would make so that it will be well understood for you. I will also attach this PDF after I complete the chapter in the description box. Please refer the video, like, subscribe my channel, and hope you liked watching it. Thank you.